Alright, today we have topic 7.1, Pythagorean Theorem. In this lesson, we are going to define the Pythagorean Theorem, and then we're going to use it to solve for a missing side for right triangles. Alright, let's go ahead and begin looking at our notes. At the top of the first page, we have our topic 7.1 Pythagorean Theorem. It tells us when two of three sides of a right triangle are known, the third side can be found using the Pythagorean Theorem. Pythagorean Theorem states that the square of the hypotenuse is equal to the sum of the square of the legs. So, with what that just said, here we go. We have the hypotenuse. Our hypotenuse squared equals a leg squared plus another leg squared. Now, this right here may be a little bit confusing. Hopefully y'all have heard about the Pythagorean Theorem. And typically what you will hear about the Pythagorean Theorem will be right over here. Let's go ahead and fill it into this box. You've probably heard that a squared plus b squared equals c squared. Let me go ahead and fix this C looking a little bit better. So the Pythagorean theorem that most people reference will be a squared plus b squared equals c squared. Let's go over here and let's fill in a little bit. This, if we're going to look at our triangle, we're going to be filling in a leg, and a hypotenuse in these squares. Obviously, from the get-go, you can't fit the word hypotenuse in here or here. So this will be the hypotenuse, which is the longest side, the side opposite your right angle. But that will be our hypotenuse, otherwise referred to as our C. So that leaves these two to be a leg and another leg. It does not matter. We can call this A and this B. You can call this one A and this B. It really does not matter. You're squaring them, then adding them together. This one can be A, this one can be B, vice versa. The only one that matters is C. C matters. It is the longest side, the one opposite of our right angle. So, let me scroll down here a little bit. Let's look at example 1. It asks us to find the value of x. So, if I was going to come over here and I was going to label, let's go ahead and say this is A. We know that this is C. We have it opposite of our right angle. And so this one would be B. I'm going to write down my Pythagorean theorem. A squared plus b squared equals c squared. Now let's go ahead and fill in the blanks for what we know. We've got a 3 and a 7. So 3 squared plus 7 squared, our a and our b, that's what we know, equals, we don't know. This will be, we can call this, we have an x value for it, so let's go ahead and plug it in, x squared. Alright, 3 squared will give you 9 plus 7 squared, 49, is equal to some other number squared. 9 plus 49 is going to give you a 58 equals x squared. The next thing that we're going to do is we're going to look to take the square root of both sides. So at that point, you're going to be left with an x equals a square root of 58. Now, we know that this is not a perfect square. There's not any two whole numbers that you can immediately say times one another or squared will give you 58. So if you go ahead and put that into a calculator, we can have this, or when you type that into a calculator, if we're going to go ahead and move it to, let's go ahead and jump to 2 decimal places, you will get a 7.62. Take that little tail off the 6. So x is equal to the square root of 58, or 7.62. This will be our final answer. Go ahead and put me a little square around that. Alright. Moving down a little bit. Example 2. Well, let's look. We've got some interesting numbers that we're going to be dealing with here. Let me grab color. We've got, alright, so here's our C, and it doesn't matter. We're going to go ahead and label A and B. So, Pythagorean Theorem, A squared plus B squared equals C squared. Now let's see what's going to happen right here. A lot of people, whenever they come into this, they see, oh man, we're dealing with a square root of 2. Well, whenever you put it into this, you're going to see exactly what happens with that. So, our A, I'm going to just rewrite real fast. A is a 6 squared. B, we don't know B. We're going to put that as our x squared. So plus x squared equals our C, which is all of this. We'll put it in parentheses because we have more than one thing we're dealing with. 6 is the square root of 2 squared. Alright. Now, I'm going to go ahead and I'm going to begin working left to right. Let's go ahead and solve this. 6 squared will give us a 36. We don't know here, so it's still an x squared. Now it comes to the part that people tend to fear the most. Let me grab another color to show what we're going to work with here. We have our parentheses, a 6 square root of 2 squared. Now, when working these, we will take this 2 and we're going to square both of these before we multiply together. So, a 2 times a 6, or I'm sorry, not 2 times, we're going to put it, and it's going to be a 6 squared. And then we're going to have a times a square root of 2 squared. Our 6 squared, we know from right over here, is 36. So 36 times the square root of 2 squared. Square root squared. These cancel each other out. So now we're left with 2. 36 times 2, 72. So we can say this equals 72. Alright, so now we're getting a little bit closer here. We have 36 plus x squared equals 72. To go ahead and keep solving, we're going to leave the variable on one side, so minus a 36 here. What we do to one side, we have to do to the other. Leaves an x squared over here equals 72 minus 36 leaves you with 36. So, x squared, take the square root of it, take the square root of both sides. It's going to leave you with an x square root of 36. We should know that right offhand. 6. So x equals 6. This is where, if you remember me mentioning it multiple times, looking at this side looks much, much larger than this side. Just because it looks does not mean that the problem is going to work out the way you would think it. If it does not have a right angle right here, if it doesn't have this symbol, do not assume that that equals 90. It must state it with the way that it's written. Alright. Alright, page 2 of our notes. We have example number 3, and it's asking us to find the value of x. Now, looking at this is not a triangle. We have a different shape here. But as you can see, it's already got nicely drawn for us. We have this split. What we have to be able to determine is, by using this, what are the lengths of this side and this side. If these two are 90s, well, then we can go ahead and we can say we've got a 90 here and a 90 here. This side is 5. This side is also 5. And if we have a 5 here, what is left over for this 11? 6. Alright, and here we have an 8. Okay, so now we have, if this is right triangle or right angle, this is a right angle. Going to form two right angles. We have here a right triangle. Let's use our Pythagorean theorem. Let's grab another color just for labeling purposes. This is opposite, so that's our C. And I'll label this as a B. So my A is an 8 squared plus a 6 squared. Notice I went ahead and skipped it. We know A squared plus B squared equals C squared equals an X squared. Alright, 8 times 8 is going to give you a 64 plus 6 squared, 36 equals some other number squared. 64 plus 36, 100 equals X squared. Let's take the square root of both sides. That's going to just leave you with an X over here equals square root of 100 or 10. So our X equals 10. Alright. Example 4. Let me scroll down just a little bit. Example 4 asks us once again, find the value of X. So let's look at what we have here. This is a little bit different. Let's say, okay, we already know that all of these sides are what? They're all the same. They're all congruent. We have one line throughout all of them. So this is an X. This is an X. This is an X. We also know that our hypotenuse, let's go ahead, we can eliminate our thinking on this side. We're only after the value of X. So here's our right triangle. We know that A, we'll go over here and snag a bright color here. We can say this is an A, this is a B, but this has to be our C, which is 5 to the square root of 2. Our A, which is an X squared, plus we have another X for our B squared. I'll write this up here to make sure, because this one's a little bit trickier, equals C squared. All I did was I said A is X, so I filled that in. Our B is also an X, so I filled that in. C is a 5 root 2. Put all of this in parentheses because we're squaring it all. Now, let's solve just like we would any other equation. We have here an X squared plus an X squared. What is X squared plus X squared? 2X squared equals, just as I did before, we're going to take this squared and we're going to take it to both items inside these parentheses. So you have a 5 squared plus a square root of 2 squared. 5 squared being 25, not plus, excuse me, let me erase this, times 5 squared times the square root of 2 squared. So you have a 25 times, these get eliminated, 2. 25 times 2 gives us 50. So, go ahead and grab our old color. We know that this is equal to a 50. Divide both sides by 2. X squared now equals 25. Square root of both sides. Ooh, that was pretty bad. Square root. Let me go ahead and remove those. There we go. Make sure we show square root. Leaves you with an X, and it equals the square root of 25. We know has a perfect square of 5. So our answer is X equals 5. Alright, example 5, our last one for this page. Find the length of a diagonal of a rectangle with the length of 8 and the width of 4. Okay, so let's go ahead and draw a rectangle. Let's see here. Let me go down here and play a little bit. I'm going to draw a rectangle. There we go. Good sized rectangle. And we're going to be looking at a diagonal of it. So there's a diagonal. It tells us that a rectangle has a length of 8. So our length here is an 8. And our width here is a 4. We know by definition of a rectangle that this is a right angle. Therefore, this is our hypotenuse. And it wants to know the length of this diagonal. So, if I was going to look at writing a Pythagorean theorem of this, this can be an A, this can be a B, and this will be a C. We don't know what what the diagonal length is, so we're going to call it an X. So let's go over here, and let's go ahead and fill in. A squared plus B squared equals C squared. Our A is a 4. 4 squared. Our B is an 8. And our C, we don't have a C, that's our X squared. Alright, 4 squared, 16, plus 8 squared, 64, equals our X squared. We still do not know that value. Let's add these two together. You will get 80 equals X squared. Taking the square root, make sure that 8 looks a little better. Square root of 80 off the top of your head. We don't have the perfect square root of 80. So we're going to say an X equals the square root of 80. Now what we can do though, and what I expect you to be able to do, is let's go ahead and let's factor this down. Let's factor our 80 to, let me go ahead and grab a different color here. We've got an 80. We know that an 80 is a 2 times a 40, which is also a 2 times a 20, which is a 2 times a 10, it's a 2 times a 5. Now, since we're pulling out squares, we're looking at pairs. So, here's a pair of 2's. Here's a pair of 2's. And what does this leave us left over? But a 5. So if I was going to look at factor this, we can pull out a 2. So I'm going to leave my x equals. I have a pair here, so I'm going to pull it outside of my square root. Now if this was cubed root, you'd be looking for 3 of them. But this is square root. Squares have the little 2 symbol. If I was going to write this correctly, that's what I would be looking at. There's a 2. So I'm looking at a pairs of, it can be a 4 and a 4 as long as there's a pair of them. 5 and a 5. Does not matter. I've got one pair here, so I'm going to pull out one of the 2's. I've got another pair, so I'm going to multiply it by the other thing that I'm pulling out, which is another 2. What's left over? Put it back underneath that square root. So x equals 2 times 2, or 4 times the square root of 5. You can also, if you put that into a calculator, you can also write or. Now I expect this. Now this would just be a little added bonus if you wanted to go ahead and quickly put it into a calculator. It's going to give you an 8.94 if we round it. So here is your main. Oh, let's go ahead and get our answer color here. There is our real answer. X is equal to 4 to the square root of 5. Alright, so let's go ahead and take the last page of our notes real quickly. Example 6, find the length of a diagonal of a square with a perimeter of 24. So quickly, let's sketch ourselves a square. And a diagonal, since that's what we're going to be after. There's a diagonal of a square. Alright, now let's talk about finding the perimeter. We know that a perimeter of any figure, P equals the sum of all sides, which we can say sides is our S. The special thing that we're going to know about a square is the perimeter of a square is equal to 4 times our sides, because all of our sides are the same. We have 4 sides to the square, they're all the same. So we can say perimeter of a square equals 4s. In this case, we know our perimeter is 24. 24 now equals 4s. So now let's solve for our s. Our s, which is our sides, is equal to a 6. Come over here with a different color. We can say we have sides all equaling 6. Now, since it's a square, we know that this is a right angle. We can also now say here, opposite of which, this will be our hypotenuse, which is also our diagonal. We don't know what it is. I'm going to put an X. So, let's use our Pythagorean Theorem. And we don't have to really focus on this part of it. Here's our triangle. Here's our A. Here's our B. And here's our C. Plug this in. 6 squared plus 6 squared equals x squared. Alright, 36 plus 36 equals an x squared. Alright, 36 plus 36. 72 equals x squared. Now let's take the square root of both sides. I'm going to rewrite in x equals square root of 72. 72 does not have a perfect square. Therefore, we've got to see if we can break it down. Let's see if we can factor 72. I'm going to take it right here. We've got 72, which is, we know we can divide 2 into it. That's our lowest number here. 2 times 36. 36 we can divide by 2. Gets us an 18. We can keep dividing by 2. Now here we can't divide by 2, but we can get 9 is a 3 times a 3. So let's look at this and let's look to pick out pairs. Since we're dealing with square roots, we're dealing with pairs of 2. So there's one pair and here's a pair. So let me rewrite. We've got x equals, let's pull out one of these pairs, 2, multiply it times, what else can we pull out? A 3 times whatever's left over, which is a square root. And we have a 2 left over. So x equals 2 times 3, or 6 times the square root of 2. Now, you may have already noticed something. There was a problem earlier in our notes that had something similar to this. A little bit of foreshadowing of what we have coming up. Let me snag a different color. We will learn special properties of right triangles, and our right triangles who has 2 of the same sides. Here is 6 and 6. We would have already known x pretty quickly. What we will learn is this will be an x, x, and this will be x times the square root of 2. Every time, x square root of 2. So no matter what we put in for x, we would put in that number times square root of 2. Looking at this example, 6 and a 6, 6 square root of 2. If this would have been a 10, 10, and a 10 here, we could have put 10 the square root of 2. We would have already known. That's going to be coming up. Quick little bit of foreshadowing. Now let's look at our last problem real quickly. Find the value of x in the isosceles trapezoid shown below. Now, let me go ahead and snag this color here. If this is 90 due to the linear pair, that is also 90. Same holds true there. If these two are 90 degrees, then we have a rectangle. We have an 8 and an 8. And what do we know about this side opposite? This is a 10. So we want to know the whole length, but we know from here to here is 10. Now we are after these two. If you look at these two triangles that are formed on the outside, let's call this one triangle 1 and this triangle 2. Our hypotenuse, this is how we can really determine. Look at our hypotenuse. Both of them are 10, and one of the legs is an 8. So these things are almost, they are identical. One of them is just flipped. So if I put an X up here, I can also put an X here. Let me redraw real quickly. There's a triangle. That's what we're looking at. That is this taken and put right here. So if I was to rewrite our numbers, we have an 8, a 10, and an X. An X is what we do not know. So let's look at this figure and let's use our Pythagorean theorem and solve. We can call this an A, this a B, and this a C. So coming over here to solve for A squared plus B squared equals C squared. C squared is 100. There, let me go ahead and fill out. Let's just say C is 10, put that squared. B is an 8, square that. And A is our X. So X squared plus 8 squared, which is 64, equals, here is my 100. Subtract 64, X squared equals 36. Take the square root of both sides, X equals 6. So we can come over here now and we can say, well, if our X is 6, then we know that this entire length, that's what we're after. We're after the entire length, which would give us the true value, I guess, of X, this X. But the entire length, say X equals 22. Now, if you do your work similar to what I did, make sure to go ahead and put your square around your final answer. There's your work shown, but we just happen to use X as a different variable. We should have probably used a Y or Z or something like that to make sure that our X value is not mislabeled whenever it comes down to the end. Now, here's another bit of foreshadowing. We could have figured out this value. Go ahead and grab a different color here, maybe. Yeah, I got it. So this value, we could have figured out very quickly without having to do any of these steps. You will hear in the future notes of the properties of a 3, 4, 5 triangle. Now, a 3, 4, 5 triangle is going to be similar to this. Let's take and look at this example. 4 times 2 is what? An 8. 5 times the same 2 is a 10. So therefore, we know we've got our two sides of a triangle, with the largest side being our hypotenuse, that if you multiply 4 times 2, you get the 8. 5 times 2 is 10. 3 times 2 gets you our 6. We can take this with any of these real quickly. You don't have to write this down, but if I was to draw another triangle, and it's a right triangle, and I'm going to come over here and I'm going to label. I'm going to say, well, this side is a 20. This side is a 15. So let's look and compare, and let's see if we can find a 3, 4, 5 rule that would apply to this one to go ahead and find what this is without having to plug this into our Pythagorean theorem. So I want to try to get on my smallest number. This will be my smallest number down to a 3. What do? I divide by 5. 20 divided by 5 equals 4. So we know the magic number is a 5. 3 times a 5, 4 times a 5, 5 times a 5 is 25. That's what we're going to use in the future. There's several special triangles that will follow this pattern. That's not just a 3, 4, 5. 3, 4, 5 will probably be the most common that we deal with. But there's just a little insight to what we have coming up next.